So we're going to say PI, this part is mechanical energy. So it's MEI equals MEF. So technically, there is one major concept in this whole problem, and that was mentioned, and that's conservation. Conservation of momentum, conservation of energy. So that was a very good answer by table 2. Okay. Now, and you remember the problem with the ugly thing? Yeah, the rat, that ugly female rat thing. I told you would see that again, and here it is, right? Because this thing goes up a height h, and h is equal to L times 1 minus cosine theta. Okay, and you can see that problem for that algebra, so I don't have to do that again. And then here, so what we're saying of the softball, momentum of the box will equal the momentum total, because this is a what type of collision? Wow. Okay, I don't want to. Because it sticks together. The ball sticks in the box. If the ball blasted through the box, well, no, if it bounced off the box, so if the box was like, I don't know, steel or something, and the ball bounced off, that would be different. Volume, they'll get mass of the softball plus mass of the box times some velocity. What are you looking for? I didn't even write that down. Oh, we're looking for the mass of the box, right? Yeah. I did write that down. Okay, we're looking for the mass of the box. So here I can find it if I can find the velocity of the two things together. Now, if I take a ball and I throw it up in the air, take a ball and I throw it up in the air, what kind of energy did it have when it left my hand?
Oh my goodness.
Yeah, right when it left my hand, what kind of energy, as it was flying through the air, what kind of energy did it have? Very good. Kinetic energy. Is everybody cool with that?
Yes.
Does it make sense to you that if I toss a ball right here and it goes up to barely touches the ceiling and then falls back down? If you know exactly how high I tossed it, can you tell me how fast? Well, let me not answer. Can you tell me how fast it was leaving my hand? How would you find that out? Alan. Kimberly's already told us that it has kinetic energy when it left my hand. What kind of energy does it have up there? So, do you see where I'm going with this? What do? Is it that no one knows what to do? Or are you just afraid to talk? How about David? What do? And yeah, so that's it. All I do is set the kinetic energy equal to the potential energy and solve for my initial velocity. So that's essentially what we're going to be doing here. We're going to say that there was some kinetic energy when the ball got stuck in the box. We know that because of V. And then that's going to equal the potential energy due to gravity. So that's going to be 1/2 mv squared equals mgh. And so you see here, the m's cancel, right? Because the total m is just the mass of the ball plus the mass of the box, or the softball plus the box. So from this, I get v is equal to the square root of 2gh. And I know h, so I can say v is the square root of 2gl 1 minus cosine theta. And now I can solve, or mb is going to equal msvs minus msv all over v. So now I can just take this velocity, stick it in there, solve it, and get my solution.